You're welcome to my channel, Mindset Academy, where we want to solve a problem involving CAM. And the question goes like this: it says, a plate CAM to operate a roller follower 0 to 150-degree lift, 32 millimeter with uniform acceleration and retardation, 150-degree to 240-degree dwell interval, 240-degree to 360 fall 32 millimeter with uniform velocity, cam rotation clockwise, minimum cam radius 24 millimeter, roller follower 12 millimeter diameter, cam shaft diameter 24 millimeter. Now, what you just do is to draw a table and input those data that is being read from the question, right? Each, depending on how you want to do it, each division of this lines is 10 millimeter each. You can use whatever you feel like doing, and each of these points here, just like your title block, is 2 millimeter or 3 millimeter, because the main diagram, the main words are not touching the outlines, but they are in between the lines. So that's just it. Now, when you input your value, your parameters, will call them the what? The CAM data. These are what we call the CAM data on the tabular form. It is very important. Now, the next thing you have to do is you draw your horizontal and what? And vertical line this way. You draw your line this way. This is the horizontal line. You can see that. And also, you draw the vertical line also. And this is your vertical line. You can see that. And they are meeting at this point here. Is that okay? Now, the first thing we'll do is to draw out the camshaft diameter. And the camshaft diameter is given to be 24 millimeter, right? So we're going to measure it on our meter rule. I can easily start from where? From 0. I'll make use of this, right? This is my meter rule graduated in millimeter and in centimeter. I'll start from 0 this way. I'll start from 0 upward. This is 10, this is 20, right? Since we are talking about diameter, you need half of it, which is 12. So I'll be coming here. This is 12 here. Is that again? And I'll place it at the center point here where they intersect. And I'm going to draw this way, which I'm going to take in. You can see that I will tick in it. Now the next thing I'm going to do is the minimum cam radius, which is what? 30 millimeter. The minimum what? Cam radius, and it's coming from the center of these two lines, right? From the center of the cam. And we told is what? 30 millimeter. So I'm going to measure 30 millimeter starting from 0 here. You can see that. Now measure 30 from here to here is what? Is 30. You can see that from 0 to 3 is 30. Then I'll take my meter rule, place it from the center point here, and I'll take it to that point 30. And what I will draw will be a faint line, not a thick line now. You can see that. Now, the next thing I'm going to do will be the lift. The lift is what? 32 millimeter, right? And to be from on top of the minimum cam radius, you measure upward 32 millimeter. So I'll place it here. Now measure 32 from this point here. So from 0 to 30, then to what? 32 is here. You can see that at this point here is 32. Or you can simply go on your meter rule and measure 32 this way, 0 to 30, and this is 32 here, right? And you can just come to this point place it here and you mark. You can see whatever you want. So from this center point, take it to that point you mark, and you draw a circle, faint line also. You can see that. Now, after doing that, the next thing we're going to do, we are told that the direction of the cam of this cam, what we're told, the cam rotation is what? Clockwise. So the cam is going in this direction here, this way. Right? So at this point here, at this point here, this way, right? So it's going clockwise, right? While the follower, if the cam rotation is going clockwise, automatically the follower will be what? Anti-clockwise. So like I said, the follower will be what? Anti-clockwise, going in this direction. So we're going in this direction. So take note, when the cam is rotating clockwise, follower will be rotating anti-clockwise. When the cam is rotating anti-clockwise, follower will be rotating clockwise, right? So the next thing you do, you're going to divide this circle into 12. Sometimes you might divide it into 24, depending on you. So let's move into what? 12. Now when I place it this way, to this point, this is how you divide your circle. Bisect up, I'll come here, I'll bisect up also with the same radius. I'll come to the upmost spot here, I'll bisect left, and I'll come here, I'll bisect what? Right. Now I will now take my meter rule and push those points through the center of this cam this way. Do for this and also for this too. You can see that. And also for this too. And also for this too. Right? So we're going anti-clockwise. Since it's from 0 to 360, we're going anti-clockwise. This will be 0 degree, 30 degree, 60 degree, 90 degree, 120 degree, 150 degree, 180 degree, 210 degree, 240 degree, 270 degree, 300 degree, 330 degree, then 360. And you might be surprised that it should be 12. If you want to do yours to be into 24, you have to just, it's easy. You can just bisect these 2 points, right? You can bisect these 2 points like this. Let me show you. Put it between 0 and 30. When you bisect it from here to this point also, right? So where they meet, I'll place it this way, passing through that point, right, to the center. Now what do you notice? 0, in between 0 and 30 is what? 15 degree, right? You can also come here also, and you bisect this point here, and this point here, right? So where they meet, I'll pass it through the center, right? This is another one, which is between 30 and 40. If you add 15, is what? 45 degree. You can see that. I can also come here also. I might not even stress myself anymore. I'll just take the division of this and this, right, which is saying this and this. So I'll just be moving them around from 90. The next point will be here, right, and the next point here will be here if I want to. So you can be using demarcation to divide everything through. You can see that with the same measurement. You can see that. So I can just take them toward the center this way. and come here also towards the center this way, right? Then from here towards the center too this way, and so on and so forth. Then here also towards the center this way. This is what we have here, right? And we can easily say, let me take this up a little bit. So we can easily say this is 60. After 60 we have 75. 15 again we have 105. After 120 we have 135. You know, so on and so forth. If you want to do it that way, right? You can continue and round it up if you want to. So if I want to with the same markation, I'll just come this way, right? And I'll move it this way. And I'll move it this way. I'll move it this way. And I'll move it this way. And also this way. And also this way. You can do it this way if you want to, right? So have it in your mind that each of them that we have here is what we have there. It doesn't really matter. This is what we have. Square. And I'll draw a vertical line here. This way. You can see that. Then we're told that from here to here is the lift, and the lift is given to be 30. So what I'll just do is I'll just measure half of 30, which is 15. 0 to what? To 15. This 15 here. And I'll place it at this point. I'll mark up. Come here also. I'll mark up. So that is 30. Right? So I'll just draw a vertical line in this manner. Right? In this manner. You can see that? And I can easily extend this too if I want to. I will not divide here. The scale here I'm using will be 1 centimeter, 0.5 represents 15. 0.15 degree represents what? 0.5 centimeter, right? 15 degree represents 0.5 centimeter, or 30 degree represents 1 centimeter. So let me use that. 30 degree represents 1 centimeter. So if I do that, if I'm using 30 degree from 0, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, right? 9, 10, 11, and what? 12. So if I'm moving there, this is the 0 degree, this is the 30 degree, this is the 60 degree, we have the 90 degree, we have the 120 degree, we have the 150 degree, we have the 180 degree, we have 210, we have 240, we have 270, we have 300, 330, and what? 360, right? So the scale is what? The scale we're using, we're saying the scale here, our scale is given to be 30 degree, or better still, 1 centimeter represents 30 degree. So that's what we use there. 1 centimeter represents 30 degree. So we'll move forward. Now I'm going to now take each of these points. I'm going to take them up. From here, this will go up. 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 This will go up, 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 like that. So this is what we have here. I know you'll be asking the question, what about the 15 degree and co? If I need it, it's just in between 0 and 10, because from here to here is 10 millimeter, 10 millimeter. So 5 millimeter is 15 degree. In between them is, it will be 0, 15, 30, 45, 60, 75, and so on and so forth. So when it warrants me to make use of them, I will. So let's move forward. Now we're not told that, don't forget, this is always the lift. The height of the cam profile is what is the lift. Now we're told 0 to 150 lift with uniform acceleration. Since we're told it is uniform acceleration, right? You have to do this. You're going to divide the vertical to the same amount of line you divide the horizontal. How did I mean? You're going to take your rule and you're going to draw an horizontal line, a line this way, right? And you're going to divide it into the amount of division. Now it must be an even number, right? You calculate this 0, this is 0, 1, 2, 3, 4, 5. This is more like an odd number. So I will start from here now. I'll divide it into 6 and I'll divide here 2 into 6. Is that taken? So what I'll do is I'll take my meter rule at any given division. I'll first of all clean this off, right? Ensure that here is free first of all. So let me do that. Now the next thing is I'm going to draw another inclined line this way at this point. Look at what I'm doing at any given radius. You can see that. So I'll take my compass. I'll place it here. I'll mark 1 at any given radius, 2, 3, 4, 5, 6. Similarly here also 1, 2, 3, 4, 5, 6. The same thing. You can see that. Now after I've done that, the next thing I'm going to do is I'm using my line division method. I'll now connect the last point here with the last point here, right? This way. Once I've done that, I'll now take my set square, place it here, and I will moving this way, this way, this way, this way, this way. Like that. And similarly, I'll come here also. I'll do the same thing. Join this last point here, right? And I'll have this way. Then take my instrument here, place it here this way, right? And I'll move this way, this way, this way, this way, and this way. So this is what we have. So the next thing is I'll take the center point. The reason I'm doing this because this is 0, 1, 2, 3, 4, 5. Assuming it is 6, I won't do this, right? So just know that the amount of division here must be equal to the amount of division here. Now join the center point here. This is the center point. I have this. And this is the center point here. This 0, 1, 2, 3, 0, 1, 2, 3. This is the center point. Are you with me? 0, 1, 2, 3, 0, 1, 2, 3. So this is where they are meeting. And I'll now draw a diagonal that will connect this point to this point through the center this way. You can see that. So what I'll do next is I'll transfer this point I marked here. I'll mark it here, the same point 2. Mark it here, the same point 2. I'll mark it here and this also. I don't want to rule a line. So all these points, I transfer them to this point here, right? So what I'll just do next is I'll take this to touch this, and I'll take this to touch this. Similarly, I'll come here also, take this to touch this on this point here, then this also to touch this. You can see that? So what I'll start is, this point you're seeing here, I'll move it to touch from the base, to touch this first line. The second point here you're seeing here, I'll move it to touch the second line, right? The third point is already there, which is here. So this is a point. This touching the first one, the second one touching here. So this is a point here. Here is a point. Then the third one touching the last point here. I'll do from the top also. This point touching the first line. This first line here. The next one touching the next one here. Then the final one touching here. So this is my 3 points that I need here. So I'll now take my French curve and I will join this arc. This is what we have here. You can see that? That is what we have from this point to that point. So this is what we'll talk about uniform what? Acceleration or retardation. So this, when you do this, whenever you hear that word uniform acceleration or retardation, you have to do this. And we're not told that from 150 to 240 is dual. Then I'll just draw this as 150 to 240 is dual. So I'll just take this on this point straight down to here. You can see that? Now the next one is 240 to 360 uniform velocity. So what it does when you hear the word uniform velocity, you just have to draw a straight line from here to here. So uniform velocity is always a straight line. Uniform acceleration, you are going to do this, right? Now we'll move forward. We've successfully completed we know this place is what? Uniform what? Let me write it here. Uniform velocity, right? Velocity, and it's fall. It's fall with what? Uniform velocity. This is dual, and this is what? Uniform acceleration, right? From here to here is the uniform what? Acceleration. Now let's move forward. Uniform acceleration. So we'll go forward. Now we want to draw the displacement of the cam displacement diagram. This is a profile diagram. We want to draw the displacement what? Diagram. So what you simply do here is this. Don't forget your normal marking we've done before, which is 30, 60, 90, and what? 120. Those ones are still intact. So what you just do is you now project those points, those main line, to go and touch the curve. You project it to go and touch the curve. You project it to touch the curve. Right? So when you've done that, so move from 0. This is 0. This point here is what? 0. Right? Then the next one is 30. So I'll go to 30. This is a 30, the line of 30 here, where it's touching the curve. I'll place it at 30. Right? I'll come again for the line of what? 60. From here to this point is 60. I'll come to 60. Place it here. Your point must be on the what? The minimum cam radius. That will be your reference point. Right? So the next one is 90. I'll go to 90 here. I'll come to 90. I'll mark. Then I'll come to the next one is 120. I'll come to 120. I'm going to mark from here to this point. Is 120. Then 180. This is 120 here. Then 150 is here. Knowing fully well that 150, 180, 210, and 240 they are all the same points, and they are at the highest point here, right? So that means 150 is on the 105, 180, 195, 215, all of them to what? 150 to 240. They are all resting. So from here to here it is resting to 240. That's why you see the straight line. They are all on the same point because from here to here, right, is from here to what? Here, touching this line here. Now the next one is 270. I'll go to 270 now. 270 is touching here. You can see that. So I'll measure 270. This is 270. From 270, which is this. So I'll just place it from here to 270. The next one is 300. This is 300 here. The line of 300. The next one is 330. This is 330 here. The line of 330. Then 360 is just falling on this point. You can see that? And we're now told it is a ruler follower, right? And what is the diameter of the ruler follower? The diameter of the ruler follower is given to be, what is it? Here, 12 millimeter. So I only take half of it. Half of it is given to be 6. So I'll just measure 6 from 0 to 6 here. Can you see that? And now every point that I mark, I'll be drawing my this first one here is thickened. Right? The first one here is what? Is thickened. Then the next one will be faint line, which is on 30. Which is what? On 30, I'll draw. The next one is on 90. Another faint line. The next one. So is on 90 here. 60, 90. All those points you just roll down those points there. You roll down those points there. This is 150. Then 240. Right? Then we have 270. Then we have 300. And we have 330. So if you like, you can be doing your 1545, but still the same thing, right? I can see come here, they're all dwelling at this point here. or this point is what is dwelling, or this point they are dwelling if I want to do that, right? But not really necessary. They are dwelling here. So not really necessary, right? So I'll now take my French curve and I'm going to combine those points together from here. Tangential arc. This will be coming like this. Then this will be going like this. This one too coming like this. Then all the rest will come here. Here too. And here too. And here. So this is what we have, right? This is what we have. So this is the cam displacement diagram, right? And this is the cam profile diagram. So we successfully reproduced the figure that you can see that is displayed on the screen. This is the rise with uniform acceleration, the fall, right, with uniform velocity, and the dual. So if you found the video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.